Okay, class. The next is we try to we will go to next section 3.2. That is your method of percentile matching. So the first method we have learned that is using the method of moment. Okay. So now we use another method that is your percentile matching. So this method is a bit complex compared to the method of moment. Okay. So percentile we have learned a little bit the concept from this theory here. Okay. But now we go further. Okay. So we can use this percentile matching to measure the parameters of the distribution. Okay. So here we go. As I mentioned in class, for tutorial class, I wouldn't post a code in Facebook because you supposed to be in my class now. So we only got one group of the lecture. We no other group. Okay, so you suppose in my class now. Okay, here we go. Section 3.2, Method of Percentile Matching. Let 100p percentile be denoted by pi p at theta, where the CDF at pi p given the theta, which is equals to p, where the p is bounded from 0 to 1. Let pi p hat denote the smoothed empirical estimate of the 100p percentile. And this can be explained by a diagram. Suppose this is a graph of PDF, and at this 100p percentile, that means at this estimate of pi p probability, which is equals to p. For example, if p is equal to 0.67, then the 100p percentile, which is equals to 67 percentile. So this can be explained by a diagram that under this graph of PDF, so at the estimate of this 67 percentile, then the probability of this area is 0.67. That is the CDF at this estimate of 0.67 percentile, which is equals to the probability of 0.67. Okay, so before we go further, I want you to understand what it means by the percentile. Okay, so percentile, p percentile actually 100 p percentile actually represented by this pi p. Okay, in risk theory, remember I told you pi p actually is an observation. If let's say this horizontal is an x-axis, okay, that is represented by the observation x. That means pi p actually is one of the observation of x. Our x usually is referred to the claim or the loss, right, from insurance company. So this pi p actually is also referred to the claim or the loss. Or in other words, actually this pi p, in fact, it's a money. Okay, so that is a data in terms of money. Okay, so I hope you get it. And at this pi p here, before under the graph of PDF, below this pi p, that is the probability is p. That is, if your p is 0.7, that means this 67 percentile represented by pi 0.67. So the area before this point, okay, above 0, because usually our observation is start from 0, usually because the claim never negative, okay, so it can be 0, usually. So that means this graph from 0 until this value, that is a 6.67, the area. That all we call is the probability. Okay, so you have to know what it means by the percentile first, before we go further. Let's carry on.
A percentile matching estimate of data is any solution of the following m equations for k is equals to 1, 2, 3 until m, where p1, p2, p3 until pm are the m arbitrarily chosen percentiles. It means that at the parameter of data, this equation is fulfill the distribution. From the definition of percentile, the equation can also be written as this for the CDF at the estimate of 100p percentile, given the parameter data that the probability is pk, where k is from 1 to m.
Okay, so this line we just want to explain here, right? Because the CDF, okay, the CDF of pi 0.67, that is exactly is equal to p, right? That is here. The CDF at this pi p, the probability is pk. Depends on what is your k. Okay, so I hope you get it. Always your percentile will refer to the CDF, please. Your percentile is a connection to the CDF, please. So we are not talking about first or second row moment. We are talking about the percentile. We are talking about the CDF. Okay, now we go to next.
Where k is from 1 to m. The smoothed empirical estimate pi p hat of the 100p percentile is found in the following way. Number 1, order the sample values in non-ascending form, that is from x1, x2 until xn. Second, find the integer m such that this inequality holds. That is, the probability p multiply the m plus 1, which is bounded by m and m plus 1. Third, the estimate of this 100p percentile, that is pi p hat, is found by taking the ratio approximately, where this pi p hat is given by this equation.
Okay, so the next 3 steps are very important, class, because you need to calculate what is the pi p value. So this pi p value, you can use the number 3 formula to calculate, provided you know what is your m. Okay, provided you know what is your xm and xm plus 1. All this can be found by second equation, this inequality. Okay, so from the second equality, that I can calculate what is my m, what is my xm. And the first very important is you must rearrange your data in non-descending form. Okay, that is, you have to start from the lowest data to the largest observation. Okay, so I show the proof and I'll show example later. Okay.
So we can prove these two results. Let's look at the proof of result 1. Consider the non-ascending n samples as follows, that is x1, x2, x3 until xn. Let the pi p hat denote the 100p percentile observation such that this inequality holds. That is, the pi p hat is bounded between xm and xm plus 1. That is, the pi p falls on here. Then this observation at xp times m plus 1, which is equals to the pi p hat.
Okay, so class, this equation, this one, I don't know whether you understand or not, but maybe I explain to you later with Word document. Okay, now at this time you just accept first. Okay, so assume that this p percentile is false on here. That is in between xm and xm plus 1. That is this. Okay, so I try to explain detail if you can't understand this. Okay, carry on.
Note that this inequality minus the xm and divided by xm plus 1 and minus xm, then we will have the following inequality, that is the pi p hat minus xm, which is bounded by xm minus xm, that is 0, and xm plus 1 minus xm, and divided by xm plus 1 minus xm. So this divide the xm plus 1 minus xm, and this will be 0. So this is 1. Now let h be the ratio such that h will represent this, where the h is bounded from 0 to 1. And next we look at the following diagram. If the ratio of the length of xm to this observation, which is h, compared to the ratio length from xm to xm plus 1, which is 1, then m plus 1, you will have m plus 1. Therefore, m plus h will be equals to p times m plus 1. That is, m plus h is equals to p times m plus 1. Or in other words, we say that this h is equals to p times m plus 1 minus m.
Okay, class, this statement you must understand. Okay, you can see very clear here. If you take the whole ratio is 1, not the length, if you are talking about ratio. Let's say the ratio from xm to xm plus 1, the ratio is 1. Okay, ratio is 1. So this ratio is h. That is, we take from here. You can see that this from here you will get this, right? From this one, each divided by each minus the xm, then divided by xm plus 1 minus xm, so you will have this. Okay, so that means if you let this as h, then h is bounded from 0 to 1. That is here. If this is a h, so from this h here, that you can see this ratio actually is equals to this length divided by this length. Right? So this diagram actually is come from here. You can see very obvious. This h equal to this, and this can be reflected by the diagram. So I assume that the ratio of xm to xm plus 1 is 1. Then this must be h. Okay. So once you know the length of this ratio is h and 1 here, then you can see m plus 1 is m plus 1 here, right? This m plus 1, I will have m plus 1. So that means m plus h will be xh. that means my H is equal to this Pm plus 1. M plus H will be equal to P times N plus 1. That is here. So, okay, so you have to know how to get this equation. Okay, from here, then we will have the next. I will tell you how to get this later. Okay, why this equal? I tell you later.
Now, since the H is bounded from 0 to 1 inclusive, therefore, this result is bounded from 0 to 1 inclusive. And if we rearrange, then we will have this probability multiply n plus 1, then we will have the lower bound, which is m, and the upper bound, which is m plus 1. So we prove the first result. Now let's go to the proof of result 2. Since equation 1 equals to equation 2, therefore, the first equation, that is this, that's the pi p hat minus xm divided by xm plus 1 minus xm, which is equals to this equation, that's the probability p multiply n plus 1 minus m. So therefore, we simplify this, and this pi p hat, which is equals to this multiply this, I will have p times m plus 1 times xm plus 1 and minus p times m plus 1 times xm and minus m times xm plus 1 and plus m times xm plus xm. So rearrange this, we will have m plus 1 minus p times n plus 1 and multiply xm plus p times m plus 1 and minus m, and the whole result multiply the xm plus 1. So we complete the proof for the second result. From this result, what is the estimate of this 100 p percentile if p times m plus 1, which is m, and if xm equals to xm plus 1. So you can try it, you just substitute this p times m plus 1 as m inside here, and also again you can substitute xm plus 1 as xm, and you simplify, you will get the result of this pi p hat.
Okay, to prove the first and second result is quite easy. Okay, so you just try to equalize the equation, you will get it. Now, for part A, what is the result? You can see obvious, right? If this p times m plus 1 is m, that means now my m minus m gone already, left only 1. So here I have an xm. Here will be 0, right? Because when this is equal to m, the whole thing becomes 0. So that means your pi p actually equal to xm only. Okay, you substitute, you will know. As this also the same, you do yourself for part B, you will get the result. Because certain questions in the tutorial, sometimes they will involve this. Okay, they will involve, you no need to memorize the formula, you just substitute, you will get the result. Just do one more step only. Okay. Now let me show you. Just now I told you that how it make this. Okay, this one. How can I have this after then? Okay, that is this. How
xp times n plus 1, which is equals to the pi p hat.
Okay, how to get this result? So remember, this is our observation. Pi p is our observation. So under this p percentile, so this acts at this, okay, at this value that is equal to this pi p observation. Okay, let me show you by taking this. I use a Word document to explain. Okay. Okay, I show you this. Let's say, for example, you have a 4 data, for example. Okay, you have two, 3. You have 4 data, 2, 3, 6, 7, for example. So that means your n actually the number of observation. You have 4 data, right? 4 data. And now let's say I want to calculate for the p, which is your p just now is 50%. Okay, 50%. Let's say your p percentile is 0.5. Okay, 0.5. So your okay, so I want to calculate this, right? So I want to know what is this result. Okay, so you can see our p times n plus 1. So which is equals to our p is 0.5. Okay, and then times n plus 1, that is your 4 plus 1. Okay, so that is 5 divided by 2, which is equal to 2.5. Okay, so that means this value, the xp times it, okay, now you can see your xp at this value. That means x, what is the observation at 2.5? This is my x1. 2 is my x1, 3 is my x2, and this is my x3. So where is my x2.5? My x2.5 actually is the midpoint of 3 in between 3 and 6, right? 2.5, that is here. Okay, so this one actually is the average. Okay, so you will have this. So this is my pi. This is my pi value. Okay, in other words, actually this is my pi 0.5. Okay, so you know that for quartile, this is my second quartile, right? Second quartile is a 2/4 because I only have 4 data, right? So we are not talking about percentile. Let's say we talk about quartile. It's the same quartile and percentile because this is a 50%. Okay, in the second quartile is also 50%. A percentile also 50%. It's the same meaning actually. So let's say you talk about quartile. So quartile is a 2/4. The formula I should say that this is 2.5 value. Okay, this is a 2.5 value. So at the 2.5 value that is here. Okay, that is in between 3 and 6. So this is the observation X at 2.5, which is 4.5. That is, you take the average between 3 and 6. So that means this is my pi, the percentile of 0.5, the percentile at 50%. Okay, so I want you to understand that what is the meaning for this. Okay, so I want you to understand just now why this is equal. Okay, because it's come from a very basic concept like the quartile, percentile, or this. You want to find the value. Okay, the value at this pi 0.5. So we have to use this formula. Okay, that is you have learned before. Remember, in your quartile, is this is your the value divided by the n. Okay, times the value. Okay, so I think you understand this, right? This one. Okay, this is a 2.5 value. This is not equals to answer is 2.5. Okay, this is not 2.5. This is a 2.5 value. Okay, that is here. 2.5 value, that is 4. At 2.5 value is a 4.5, which is equal to this. Okay, so I think you have some idea now. Okay, how we okay, now I go back to the notes. Okay, that is this.
Pi p hat.
Okay, that is how we get this. I explained to you just now. I just use simple quartile or percentile, 50%. Now you know already. Okay, so I think the rest, once you know this, you should know the rest because I will explain. Now for this semester, of course, I couldn't set any question to prove because all open book, right? But last semester before that, I really asked students to prove it in the exam. Okay. Now, for this section here, actually, I just want to prove these two formula, number 2 and 3. I just want to prove this. The first condition is you must rearrange the data in ascending form or non-descending. Okay, you have to rearrange, otherwise you won't get the answer. So I go to next slide. I show you the example 4, 5, 6. Okay. So let's go to example 4 now.
Example 4. A random sample of 20 observations has been ordered as follows, where the data is in non-ascending order. Determine the 60 sample percentile using the smoothed empirical estimate. So this, our aim is to find the estimate of this pi 0.6.
So this question, we do not estimate the data. Okay, we just want to calculate this observation pi at 0.6, or we say the x value. Okay, when the for 60 percentile, okay, that is a pi 0.6. Not to estimate, we can estimate the parameters, but for this question only we want to calculate this 60%, 60 sample percentile.
Let's look at the solution of this example 4. Let x be the random variable of the given data. Let the 20 non-dissenting observation as follows. That is, x1 is 12, x2 is 16, x3 is 20, and until x20 is 57. For n is 20, that is the sample size, and this probability, that is 0.6. Then, from this inequality, we will have 0.6 multiply n plus 1, which is bounded from m to m plus 1. That is 12.6 is bounded between m to m plus 1. So therefore, we choose the integer that m is 12.
Okay, clear or not? Here, after that, from here you have to choose the largest integer, which is less than 12.6. That must be 12. You must choose the correct m, the integer. Next.
Now, this will give the result of the 12th observation, which is 38, and the 13th observation, which is 39.
Okay, so this is our xm, and this is our xm plus 1 when m is 12. Okay, next.
And next, we will use this formula to calculate the 60 percentile. So we will have the estimate of this 60 percentile, which will be equal to 12 plus 1 minus 0.6 times 20 plus 1 times this 12th observation, that is 38, and plus the probability, that is 0.6, multiply the n plus 1 and minus m, which is 12. And this result multiply the 13th observation, that is 39. So this will give me about 38.6. In order to find the estimate of 60 percentile, so we need to find what is the integer of m by using this inequality. So once you have the m, you can get the xm, that is x12, and the xm plus 1, that is x13. So after that, apply all the information we found and substitute into this equation, you will get the result of this estimate of 60 percentile, that is 38.6.
So what it means by this class? 38.6 means that under the graph of PDF, the probability when the x is less or equals to 38.6, the probability is 60%. Understand? Right? Under the PDF, when the loss x, which is less or equals to 38.6, the probability is 60%. Okay, that is this. Okay, next.
Of this estimate of 60 percentile, that is 38.6. Example 5. You are given the following. Number 1, losses follow a rule distribution with parameters gamma, theta, and alpha, which is 2. Number 2, a random sample of 15 losses is as follows, that is from 195 to 615, where the data is in non-descending order. Use the smoothed empirical estimates of 30th and 65th percentile matching to estimate the parameters gamma and theta. So our aim is to estimate these two parameters by using the smoothed empirical estimate. So it means that from this 30th percentile, we need to find what is the integer m, and from here we can calculate what is the observation of xm and also the xm plus 1. And similarly, here also the same, that under this 65th percentile, we have to find the integer m, and after that we try to find the m observation and the m plus 1 observations. So from there, you will use CDF and you will have two equations, and you solve the simultaneous equation, you will have the result of this gamma and theta. Here we go. Example 5. Let x be the loss random variable such that x is rule distributed with this parameter gamma, theta, and alpha, which is 2, where the CDF of this rule distribution is given by this. Next, let the 15 non-descending observation of losses as follows. That is, x1 is 195, x2 is 255, until the x15 is 615.
Plus, I use non-descending. Okay, you may use decreasing. Non-descending is much more appropriate because some of the data may be repeated. Right? Maybe you have 2 times of 255. Okay, x2 is, let's say your 255, next is 255. Actually, it's not ascending. We only can say it's non-descending. But to me, I accept these two, doesn't matter. But non-descending actually is much more appropriate. Okay, let's carry on.
Let's look at the estimate of this 30th percentile. Now, since the sample size is 15 and this probability is 0.3, therefore, from this inequality, we have to find the value of this integer m. That is the probability multiply the n plus 1, which is bounded from m and m plus 1. So this will give me 4.8, which is bounded from m to m plus 1. Therefore, we choose m, which is 4. And this implies that, which is 280, and the x5 is 350. So we have x4 is 280 and x5 is 350. And next, by using this formula, I will have this result, that is the estimate of this 30th percentile, which is equals to 4 plus 1 minus 0.3 times n plus 1, and multiply the x4, that is 280, and plus the p value is 0.3, multiply the n plus 1, and minus 4. And this result multiply the x5, which is 350. This will give me 336. So I'm going to use this CDF to get an equation which is involved the theta and gamma. Hence, the CDF at this estimate 30th percentile, which is equals to 0.3. So therefore, the CDF at this value, which is 336, which is equals to 0.3. So substitute the x value inside here. I will have 1 minus 1 over 1 plus x, that is 336, divided by theta to the power of gamma and square it, which is equals to 0.3.
Okay, so class, you can see once I have this 30th percentile, I found that it's a 336, so I know that this is a CDF. Remember I told you the probability where the x is less or equal to this is a 0.3. So I can substitute this value, this observation, this x value, that is a pi 0.3, which is 336 into the CDF from the table C, then you will have this equation. And next I will get another equation. I solve the simultaneous equation, I will get the answer. Okay, so this is a trick how we want to use the matching percentile to calculate the parameters. Let's carry on.
So simplify this equation, I will have 336 divided by theta and to the power of gamma, which is 1 over square root of 0.7 and minus 1. Say this is the first equation. Now, let's look at the estimate of this 65th percentile. Now, since the sample size is 15 and the probability is 0.65, therefore, this 0.65 multiply the n plus 1 is bounded from m to m plus 1, or 10.4 is bounded from m to m plus 1. And now we choose the m is 10. So this will give me the 10 observation, which is 450, and the 11 observation is a 490. So this is 450 and the 11 observation, which is 490. Thus, the estimate of this 65th percentile, which is equals to the m plus 1 minus the probability times the n plus 1 and multiply x10, which is 450, m plus 0.65 multiply n plus 1 again and minus m, and this result multiply x11, that is 490. So this will give me 466. So again, we take this CDF and substitute our x as 466. Therefore, the CDF at this value, that is 466, which is equals to the probability of 0.65. So let's substitute the x value inside to the CDF. So I will have 1 minus 1 divided by 1 plus 466 divided by theta to the power of gamma and square it, which is equals to 0.65. So simplify this equation, I will have 466 divided by theta to the power of gamma, which is equals to 1 divided by square root of 0.35 and minus 1. Say this is my second equation. So we try to solve these two equations, you will get the result. So we solve 1 and 2, then we will have the result of this estimate of gamma, which is 3.86, and the estimate of theta, which is 512.96.
Okay, class, I suppose you know how to solve these two equations, 1 and 2. You just divide, right? You take 1 divided by 2, then theta gone already. Okay, then you can calculate the gamma. Then you will get the data later on. Okay, so I believe you know how to solve it. So it's simple, class, right? How to use the percentile matching to find the parameters. Okay, so this is a way. It's quite easy if you already can handle the formula. So we move to example 6 now.
512.96. Example 6. You are given the following sample of claim counts, that is 0, 0, 1, 2, 2, which is in non-descending order.
Okay, class, this question very interesting and a bit confused maybe. So you please pay attention.
You fit the binomial model with these parameters and Q with the following requirements. First, the mean of the fitted model equals the sample mean. So this fitted model is referred to the binomial distribution. The sample mean is referred to the sample data. Second, the 33rd percentile of the fitted model equals the smoothed empirical 33rd percentile of the sample. So with this information from 1 and 2, determine the smallest estimate of n that satisfy these requirements. Example 6. Let x be the random variable of the claim counts. Let the 5 non-descending claim counts as x1 equals to x2, which is 0, x3 is 1, and x4 equals to x5, which is 2. Case 1. From the sample, then the sample mean that is the expected of x, which is equals to total up all this sample 0 plus 0 plus 1 plus 2 plus 2 divided by 5, which is 1. So let's say this is my first equation. Now for the estimate of the 33rd percentile, that is for this pi 0.33 hat. Now since and the probability is 0.33, therefore this p multiply the n plus 1, which is bounded between m and m plus 1. In other words, 1.98, which is bounded between m and m plus 1. So therefore, we choose m as 1, and implies that the first observation, which is 0, and the second observation, that is xm plus 1, and which is 0 as well. Thus, the estimate of this 33rd percentile, which is 0,
Okay, class, you can substitute, right? Because your xm is 0, xm plus 1 is 0, the whole thing is 0 for the from the formula, right? So that means the pi 0.33, the 33rd percentile will be 0 as well. So if you look at before we go further, if you look at my case 1, I involve two calculation. This sample mean I use the first row moment, the row moment method, and then this one I use the percentile matching. Okay, so I involve two methods here for case 1. So let's carry on.
Case 2. Let's consider the fitted model. So let X be the binomial distribution with the parameters n and q, such that the PMF of this binomial distribution at X, which is given by this formula, then the expected of this binomial distribution, which is equals to NQ. So let this be my second equation. Part 1. Since the mean of the fitted model equals the sample mean, that is, since the second equation, which is equals to the first equation, therefore, this NQ, which is equals to 1.
Plus, here to know this is a sample, right? Fitted model is binomial distribution. So you must understand the question, okay? Because the question say that the mean of the fitted model, which is equal to the sample mean. So sample mean actually we can calculate from the first row moment. Okay, we can calculate this sample mean by using the first row moment. And this fitted model, the mean actually, your fitted model is binomial distribution, right? So then if this X is binomial distributed, the mean of course is n times the probability of success, that's NQ. Okay, so you have to understand the question before you solve the problem. Let's carry on.
Which is equals to 1. That is, Q is equals to 1 divided by n. Or we say that X is binomial distributed with the parameters n and the probability of success, which is 1 over n. Part 2. Given that the 33rd percentile of the fitted model equals the smoothed empirical 33rd percentile of the sample, that is, the PMF for this random variable X at this estimate of 33rd percentile, which is equals to the probability of 0.33. So substitute this estimate value we have found just now, that is 0.
Okay, so here class, this statement is important. I translate the question number part 2 to the mathematical language. Okay, so this statement you have to understand, otherwise you cannot solve the problem. Okay, you just look at it. I translate direct to the mathematical language.
So we will have the probability of this X at 0, which is 0.33. So place the X value inside this PMF. So we will have NZ0 1 over n to the power of 0 and 1 minus 1 over n and to the power of n minus 0, which is equals to 0.33. So you simplify this, we will have 1 minus 1 over n to the power of n, which is 0.33. Now let y equals to this. So by trial and error, we found that if n is 5, therefore y is equals to 0.32768. Now if n is 6, then the y value, which is equals to 0.3349. So therefore y is greater than 0.33, for n is at least 6. Thus, n equal to 6 is the smallest estimate value that satisfies these requirements. Please take note that this y is a monotonic increasing. So therefore, whatever x is greater than 6, the y value will be greater than 0.3349. So therefore, n equal to 6 is the smallest value.
Thus, to solve this equation, you can use Newton's method. Okay, but of course, you need to go the iteration to solve Newton's method. Remember in calculus, or otherwise you just make a simple try and error. Because I just want to know if this is, because the question say that greater than 0.33. What is the smallest integer that will greater than 33%? So you can, if you substitute n is 5, you just get about 32.76%. But when n is 6, then you will exceed 33%. Okay, so this is monotonic, means that when n is 7 and 8, this definitely is greater than 33, because monotonic means that increasing means increasing, it won't come down. Okay, so this is a one-to-one. Okay, one-to-one function. There's no others value. Okay, so when n is 7, this is keep on increasing. Okay, the graph won't come down. Just go up increasing. When n is increasing, this is monotonic for the increasing. Okay, so this is a solution that the smallest integer, the trials, the n trials is 6. Is 6. Okay, so this question very nice, that you have to understand the question. Okay, so any question to us? We have done was chapter 3, no more already. But we have many questions in our tutorial. So I have 30 minutes more. Let me discuss the one somebody asked me. Okay, let me see what is your question. Okay, let me go to the, I want to discuss the tutorial question, because we have 4 more tutorial questions for the kernel distribution. I worry tomorrow we have tutorial class, not enough time, just 1 hour for each group. May not enough time to cover the 4 questions. So let me use this about 30 minutes to cover at least 1 question. So let's go to question 11. Yesterday we have done question until 11. Now we go to 12. No, yesterday we had done until 10, right? So now we go to 11. Okay, let me check the questions. Yeah, yesterday we have done until 11. Now we go to 11. Question 11. So look at this, question 11 now.
Number 11. Based on the mortality study, all deaths occurred at times 10, 12, until 20, or after 20. The empirical distribution function is as follows. That is this, that based on this mortality data, given the empirical distribution function, estimate kernel smoothed function at 15 with a uniform kernel of bandwidth 4. So our aim is to estimate this by using the uniform kernel with this bandwidth is 4. Number 11, let x be the random variable of the mortality data. Then, given the mortality data x is given by this, that's from 10 to 20 or more than 20. Now, based on this empirical distribution function, we can calculate the empirical probabilities for each data. So here it is. So for the first probability for this data 10, of course, is 0.2. For the next data, the probability that we will take this CDF minus this, that is 0.2 as well. And next, for this data 16, the probability which is taking this CDF minus this, that is 0.1. And so on. We will have 0.3, 0.06, and 0.09, when this 0.95 minus 0.86. Next, if x is uniform distributed in this interval from xi minus 4 to xi plus 4, where the bandwidth is given that, which is 4, then the kernel density at 15 is given by this formula. Substitute our x is 15 and the bandwidth is 4 inside here and also the interval as well. So we will have this. The kernel density at 15 based on this xi, which is equals to 1 divided by 2 times the bandwidth, which is 4. At this interval, xi minus 4, which is less or equals to 15, and which is less or equals to xi plus 4. Other than this interval, the k value is 0. So let's simplify this. I will have 1 over 8 and 0 corresponding to the interval where that xi is bounded from 11 to 19, and this is otherwise. So we have to consider all the data which is inside this interval from 11 to 19. So we only consider 12, 16, 17, 19. So the kernel smoothed density at 15 will have this k value and multiply the corresponding probability. So we will have k value and multiply the first probability is 0.2 and plus 0.1 plus 0.3 and plus 0.06. So we will get 0.0825.
Okay, class, for this problem, is given the CDF, so you have to calculate the probability here. So the probability, of course, you know, this is the individual probability, this is the accumulate, right? So you should know how to calculate, right? 0.4 minus 0.2, you will have 0.2, right? 0.5 minus 0.4, you have 0.1. So you may surprise because this total probability, the CDF, whatever more or equal to 20 is not 1, it's 0.95 here. Okay, so do not think that this is a question got error, because remember in kernel distribution it's just approximately, you may not get the total probability is 1, because the kernel distribution is we try to convert the discrete into the what they call this smoothed distribution, kernel smoothed distribution. That is you may have some error that you may not get the 1. But however, this question is we do not involve this the error here, because we only up to 19. Remember, look at our range here. We only consider the data from 11 to 19. That is from 12 to 19. So this we not include. Okay, although we have some minor error here from the survey, not from the question, from the survey. So they may not get the exactly 1 year. So then not this one may not reliable because it's not 1, right? But however, it's not important, because we for this question we only calculate the observation from 11 to 19. That is from 12 to 19. Okay, so you will get the answer. Okay, I think just now your friend asked me, Jiafu, why 2 divided by 4? This is a percentage, right? 2 over 4 is a 50%. I'm talking about the quota. So quota is a 2 over 4 or 50%. Okay, so whether it's a percentile or quota is a 2 over is a 50%. Okay. So next, I should have time. I go to the one more example. One more questions. Okay, the question number 12. So that tomorrow we only cover 3 questions during the tutorial. So here, this is a question number 12.
Number 12. Losses on an insurance coverage are estimated using kernel density methods in conjunction with the following sample of 8 losses. That is this data from 15 to 100. Using a triangular kernel with bandwidth of 20, estimate the probability that a loss is greater than 40 and less than 50. First of all, we let this loss as lambda variable x. So our aim is to find the probability that when the loss is greater than 40 and less than 50. Since this loss x is a continuous triangular kernel distribution, therefore, which is equals to the kernel smoothed distribution at 50 and minus the kernel smoothed distribution at 40. So at first we try to find what is the kernel at 50, and next we have to find the kernel distribution at 40. So when we have these two results, then we will get this and the problem solved. Number 12. Let x be the loss size random variable such that x is triangular distributed in this interval from xi minus 20 to xi plus 20, where the bandwidth is given 20. Then we have the following, where the loss data is given from 15 to 100, and the number of observation of each data is 1. So the probability for each data is 1 over 8. So our aim is to find this probability for the loss, which is in between 40 to 50. Since the loss random variable is continuous in this triangular kernel distribution, therefore this is equals to the kernel smoothed distribution at 50 minus the kernel smoothed distribution at 40.
Okay, class, this is important. Our actual data is discrete. Okay, but since we have converted to the triangular, that has become the continuous. So therefore, the equal sign is not important. Otherwise, it's important. If this is the discrete, then this is wrong. Okay, this is wrong. But since now your x is already in the continuous, so therefore the equal sign not important anymore. So that means this is true. Next.
Firstly, for kernel distribution at 50, that is, we have to find what is the k at 50. So we are going to substitute the x is 50 and the bandwidth is 20 into here, and also the interval as well. So we will have the following. After we substitute the x is 50 and the bandwidth is 20, so we have this result. And this is equals to, this is 0 when the xi, which is greater than 70, and this is equals to 70 minus xi square and divided by 800, at this interval, and this can be simplified where the xi is bounded from 50 to 70. And the third result here will give me 1 minus xi minus 30 square divided by 800 at the interval where this xi is bounded from 30 to 50. And last, the k value, which is 1, where the xi, which is slightly less than 30. So, based on this result, accept this 0, that whatever x value which is less than 70 will be considered. That means all the data will be considered except 77 and 100. So based on the probability is 1 over 8, then we can solve the problem. So for the first interval that xi is really less than 30, we have 2 data. And for this interval 30 to 50, we have 3 data, that is 36, 40, and 45. And for this interval 50 to 70, we have 1 data, that is 60, which is false on this result. So therefore, the kernel smoothed at 50, which is given by this result. That is, I'm going to take the probability and multiply the k value. The first 2 data had a k value is 1 and multiply the probability of 1 over 8. And next, we have 3 data with this result with the probability of 1 over 8, that I will take 1 minus 36 minus 30 square divided by 800, and the next data will be 1 minus 40 minus 30 square divided by 800, and plus 1 minus the next data will be 45 minus 30 square and divided by 800. And I have 1 data which is false on this group, which is 60. So I will take the probability times this value, that is 70 minus 60 square divided by 800. So I will have 3739 divided by 6400. Next, we have to find the kernel distribution at 40, that is this K40. So we have to use this formula again. So we have to substitute x is 40 and the bandwidth is 20 into here and this interval as well. So we will have the following. So we will get this result after we substitute our x is 40 and the bandwidth is 20 into here and the intervals. So next I'm going to simplify this. So I will have 0 where xi is slightly greater than 60, and next this will give me 60 minus xi square and divided by 800 at the interval where the xi, which is bounded from 40 to 60, and this will give me the result 1 minus xi minus 20 square and divided by 800, where the xi is bounded from 20 to 40. So the last one, the k value is 1, where the xi, which is 50 less than 20. So from this result here, we can see that all the value which is less or equal to 60 will be considered. So in other words, we will consider all the data from 15 to 60. For this interval, the xi less than 20, that we have 2 data. And for this interval 20 to 40, we have 2 data again, that is false on this. And for this interval 40 to 60, we have 2 data again, that is false on this result. So the kernel smoothed at 40 can be estimated as.
Class, do not worry about the. I told you last week, I said, because this one overlap, right? 40 overlap. So for the data of 40, you can choose this result or this result will give the same value. But you only can choose either one. You cannot repeat twice. Okay, if you repeat twice, that means you add another extra data. Okay, so for again 40 because it's overlapping here. So that means you choose this or this. These two will give you the same value. Okay, you can try same value. So next we can calculate for this CDF at 40.
I have 2 times of 1 with a probability of 1 over 8. And I have 2 times of the data false on this group with a probability of 1 over 8. So the first data, which is 36. So I have a 36 minus 20 squared divided by 800. And the next data false on this group, that is 40. So I will have 1 minus 40 minus 20 squared and divided by 800. So next, I have another 2 data false on this group with this value. So with the same probability is 1 over 8, then I can factorize. So I will have 60 minus the data, which is 45, and square divided by 800. And the following data falls on this group, that is 60. So I will have 60 minus 60 squared divided by 800. So the whole result here will give me 2769 divided by 6400. Hence, the probability of this loss between 40 to 50, which is equals to the kernel smoothed distribution at 50 minus the kernel smoothed distribution at 40. So from the result we have found just now, this is equals to 3739 divided by 6004, and this is 2769 divided by 6004. So I will have 97 over 640.
Okay, class, we have done. So you can see that for this probability, okay, between 40 to 50 under this triangular, the answer is a 9. The probability that is this. That's how much is it? If you calculate. So if you take calculator to count, you will have about 97 divided by 640. You will have 0.1515. Okay, that is we consider the continuous distribution in triangular. Now what happens if this is discrete? If this is discrete, 40 to 50, let's go back to the questions. Okay, if this is discrete, so 40 to 50 exclusive, so you only got one data here, right? That's 45. 45 divided by 8 is 0.125. Okay, based on the discrete, the probability in this range, that is 0.125. But based on the triangular distribution, so we have found that the answer, which is about 0.1515. Okay, so that is depends on you want to consider a continuous or the discrete data. So we are done for this question number 12. Tomorrow I will discuss the 13 and 14. Okay, so that's it, class. Any questions? So if no, you may go now.